And today we're going to talk about systems of equations solving by using substitution. When you solve by substitution, the first thing you're going to do is you're going to choose one of the equations you're given and solve that equation for x or y by rearranging the equation so it's in the form x equals an expression or y equals an expression. The second thing you're going to do is substitute the expression from the equation you found in step 1 into the other equation that you did not rearrange and solve. Then you're going to substitute the value that you get in step 2 back into the equation you rearranged in step 1. Hopefully that'll make a little more sense as we go through an example. In our first example, we have 3x plus 2y equals 10 and 2x minus y equals 9. First step, we need to choose an equation and rearrange it. In this case, I chose the second equation, mainly because it does not have a variable multiplied by y. And you have 2x minus y equals 9. You're going to subtract 2x from both sides. That gives you negative y equals negative 2x plus 9. Then we're going to divide by negative 1 to get y by itself. So we have y equals 2x minus 9. The second step is we're going to take that expression, 2x minus 9, and substitute it for y into the equation we did not rearrange. So we have 3x plus 2 times the quantity 2x minus 9. Right there is our substitution. Instead of putting 2y, we put 2x minus 9 in the place of y equals 10. If we distribute, we have 3x plus 4x minus 18 equals 10. Collect like terms, we have 7x minus 18 equals 10. When we add 18 to both sides, we have 7x equals 28. And when we divide by 7, we have x equals 4. Now we have half of our solution. So we're going to take the 4 and substitute it back into our expression from step 1. So we have y equals 2x minus 9, but now we know x is 4. So we have y equals 2 times 4 minus 9, which gives us 8 minus 9, which tells us that y equals negative 1. So we now know that our solution is the ordered pair 4, negative 1. That is the one point that satisfies both of these equations. Let's look at another example. Here we have 3x plus y equals 8 and 9x plus 3y equals 24. In our first step, we're going to select an equation and rearrange it. I like to look for the equation that has a variable with a coefficient of 1. And in this case, that would be our first equation. So I have 3x plus y equals 8. You subtract 3x from both sides, and you get y equals negative 3x plus 8. Now we're going to substitute that expression for y into the equation we did not rearrange. So we have 9x plus 3 times the quantity negative 3x plus 8 equals 24. That gives us 9x minus 9x plus 24 equals 24. And then when we collect like terms, our variables drop out of the equation because 9x minus 9x is 0x and 0x is 0. So we get 24 equals 24. I know that 24 equals 24 is a true statement, and that tells me that I have infinite solutions. If I graph these two lines, they would graph on top of each other. Okay, let's look at a third example. I have negative x plus 4y equals 4 and x minus 4y equals 6. I'm going to choose equation to rearrange. I'm going to choose the bottom equation. So I have x minus 4y equals 6. I'm going to add 4y to both sides. That gives me x equals 4y plus 6. Now I'm going to take that expression and substitute it for x into the top equation. So I get the negative of 4y plus 6 plus 4y equals 4. You notice the negative on that x has to be distributed to that expression. So that gives us negative 4y minus 6 plus 4y equals 4. When I collect like terms, negative 4y plus 4y is 0. So I have negative 6 equals 4. And I know that negative 6 equals 4 is a false statement. Therefore, I have no solution. If I graph these two lines, they would be parallel and they would never intersect. Okay, we're going to have some to practice. And tomorrow we'll come back and talk about elimination.